The principal components analysis that I'm doing happens to live in this function called do PCA. And it looks very familiar to a lot of the stuff that we've done before in sklearn. You have an import statement where you actually get the module out that has the code that you want. You create, in this case, the principal components analysis. You fit it, and then you can return that as an object. And so what I do is I get my principal components analysis that way, and I can ask some very interesting, some very important questions of it by accessing the attributes. So let's explain these 3 lines. This is how I actually get the information out of my PCA object. The first, the explained variance ratio, is actually where the eigenvalues live. So by printing out this line here, this is the way that I know that the first principal component has about 91% of the variation in the data, and the second one has about 9 or 10%. Those numbers come from this statement here. And then the second things that I do is I look at the first and second principal components. I get these out of the components attribute of my PCA object. So the components is going to be a list, a Python list, that has as many principal components in it as I ask for as a parameter. So in that case, I have 2 principal components that I'm getting. So I name them the first and second PC. So in previous quizzes where we were talking about what's the direction of, say, x prime in the xy original feature space, we came up with 2 numbers that were sort of packaged together into a vector. You can access that directional information through these components. Once I've fit my principal components analysis, I have to, in order to do anything, perform something like a transformation of the data. And this code I will just give you in the starter code for the quiz. What I'm doing here is I'm visualizing it. The first line is in red. I'll be plotting the first principal component, the locations of all the points along that principal component, as well as the direction of the principal component. I'm accessing that information by using the elements of the first PC vector. Then in cyan, or kind of a teal color, I'll be accessing the second principal component. And in blue, I have the original data. So let me show you what this looks like, and then you give it a try yourself in the quiz. The first thing that you get is I print out the eigenvalues. Remember, that's this explained variance ratio information. And then the second thing is that you'll get a scatter plot, and it should look something like this. So remember, the red was the direction of our first principal component, and that's hopefully exactly where you guessed it was. It certainly intuitively seems like it's in the right place. The cyan is perpendicular to that, and then the blue is the original data points. One thing that I'll add is that it looks to the eye like the red and the cyan are not perfectly orthogonal. This doesn't quite look like a 90-degree angle. But remember that our axes have different scales. That this one goes all the way out to 10 million. The y-axis only goes out to less than half of that, about 4 million. So in reality, if we were to plot everything proportionally, this graph should be twice as long as it is tall. And if we were to visualize it in exactly that way, they would be orthogonal.